Now, how can we use the reliability function or the hazard function in taking decisions regarding the design life of the item in question? We have done one or two examples with this sort of question. So let's now formalize that. So we can state that the reliability function must be above the minimum acceptable value R star during the entire service life. So that would clearly give us the design life. How we get the minimum acceptable value is obviously a very different question. It's a separate question. It's a quite a large subject in itself, and we are going to discuss that towards the end of this course. But if we know what R star is, then we have a very logical method of coming up with the design life. So that would be the time at which the reliability first falls below R star. Obviously, R function can never go up, so we are talking about cases where it can stay constant. So that's how we define the design life in terms of acceptable reliability. We can take an alternate approach and bring in the hazard function. So as I have said before, the reliability function is kind of an aggregate report on the item's performance, but the hazard function is a more local investigation on how it performs. So we can specify a maximum acceptable hazard function, as soon as the hazard function exceeds that value, that maximum acceptable value, we specify that time, we identify that time as the design life or acceptable service life. So we could likewise, we can derive the value of H star from various considerations and be able to specify the design life. And this can be more intuitive in certain situations, especially when you have an in-service structure and you need to make sure that it never becomes more unsafe than acceptable. And obviously, time to the acceptable design life or service life defined this way, you can divide that by a factor of safety, and that is the sort of approach that is taken in the so-called safe life approach. So you could factor it down to an acceptable level.